from here we'll see an entire power sequence. We connect everything.
Okay.
This is our volt-in section. Volt-in section generate the voltage
Yes.
and send output. This is my current sensing resistor, and from here the voltage spread entire motherboard. This is my always voltage section, generate a 5 volt and 3 volt. This is my sustained voltage after power on they get.
Yeah.
And here are the different pulse width modulator. 1.5 volt pulse width modulator, 1.8, 1.05, and then a CPU core.
Yes.
So how much the input voltage here?
18 ohms.
18 voltage, and the output voltage are different. Different coil have a different pulse width modulator.
Yes.
So this is a concept. This is the entire circuitry
Yeah.
of the laptop motherboard. Now where this power goes, in this section we'll see where this power goes. So this is my input section, adapter, volt-in section, and these are again the different pulse width modulator. So in pulse width modulator, here is my first pulse width modulator where the linear voltage, the always voltage is generated, 3 and 5 voltage. This 3 voltage given to the SIO. This 3 voltage given to the SIO, then 3 voltage going to the PCH, then bias, then. But how this voltage is going? Through a MOSFET. So this side voltage is called the always voltage. This side voltage is called the sustained voltage. Okay, when the power on button press, this voltage generated. Then the 1.5 voltage given to the PCH, 1.35 given to the RAM and processor.
Voltage, no?
What?
1.5 voltage run voltage.
Yeah, 1.5. These are different. It's called system voltage, run voltage. I tell you about their names. Then 1.35 given to the RAM. If it is a DDR3L RAM,
DDR3 होगा तो
3.
1.5
If it is DDR3, then 1.5. And if it is a DDR3L, if it is a DDR3L, 1.35 voltage. Okay. Then 1.05 is called a system voltage. It's called a system voltage. Then the last, CPU core and the graphics core. So these are the voltages. So these are all different pulse width modulator. Right? Now we'll go to the next section. Now we'll see here a ladder. Like in a desktop motherboard, there is a ladder. First, there is always voltage is generated. As soon as you connect the adapter, or whether it is a battery, a 3.3 and 5 volt is generated. Right? A 3.3 and 5 voltage generated. That is called always voltage. And this 3.3 volt is given to the SIO and PCH. When you power on button press, 1.5, 1.35, 1.05, 3.35 graphics core, CPU core voltage will be generated. Right? After that, power good confirmation. Power, whatever the power is given to the motherboard, it's working. Is a confirmation signal to all the chips, asking them to be ready. The power you got, which is okay. So this signal is called a power good signal. After that, there is the next signal is called the reset. The reset, what the reset do? The reset clean entire motherboard. If there is any junk information, some junk value, whether it is RAM, whether it is processor or PCH or wherever it may be, it clear by reset signal. Reset, clean it. So this signal is very important. Then the next signal is called the clock. The clock signal generate a clock frequency. Each chips require a different frequency. Each chips require a different frequency that generate by clock. CPU require a different frequency like 100, 200 megahertz. PCH require a 48 megahertz, 66 megahertz, 90 megahertz. So the SIOs require a 32.7 kilohertz, 33 megahertz. So each chips require a different frequencies.
Okay.
So that frequency is provided by clock chips. Now the clock section in Core Studio, there is a separate clock chips. In Core Studio, there is a separate clock chips
Okay.
which connected to the 14.3 megahertz crystal, which generate the clock. But in the latest motherboard, there is a PCH, and in the PCH, there is a clock inside in the PCH.
Clock IC.
Clock chip inside in the PCH. You just bring that motherboard. See, in this chips, this one is called PCH, and the clock section inside this PCH.
There is no separate IC.
There is no separate IC.
Acha.
Only one crystal is connected. This crystal is 25 megahertz crystal, and this 25 megahertz crystal generate a 25 megahertz frequency which given to the PCH, and inside the PCH there is a multiplier which generate a different frequencies which given to the different sections internal to the PCH and external to like also like in CPU, RAM or wherever it may be required.
PC, clock not come, you replace it PCH.
Ha. First you have to check the crystal 25 megahertz.
Not necessary to replace new one.
New PCH. Yes, you have to replace a new PCH only. First try to heat. First try to replace the crystal. If still not solved, then you have to replace the PCH. So that is like that. After that there is a next signal is called the BIOS. BIOS,
Available markets are all.
all the chips are available. The next chip signal is called the BIOS. BIOS is a chip where the programs written inside when CPU wake up, when CPU get a reset signal, and when the clock started, when he execute the first instruction, the CPU search the BIOS where it is, and he read the BIOS, and BIOS tell him to what to do, what command he has to execute. So that is mentioned in the BIOS. So when CPU got the first clock after reset, he started reading the BIOS. So if it is a BIOS is corrupt or BIOS is a bad, so CPU confused and he don't do anything, he just stop there itself. So BIOS give him startup initially. Okay. And what the BIOS do? He do the power on self test. The power on self test means he tests all the devices whether it is there or not. Like in our it's called attendance
Yes.
in school and colleges. Attendance, roll number 1, roll number 2, roll number 3, like that. So he tests all the devices whether all the devices are there or not. If someone is absent,
Okay.
at that time BIOS generate one code
Okay.
that we can see on the debug card, or it give the beeps, or it displays something flashlight or something. So he generate that code.
Okay.
So this is a ladder, and after that
Display.
the display will be there. Okay, so this system work like this. Yes. In last session, what we learn is different section like voltage section, always voltage section, power on section, different pulse with modulator. Then we combine all these things,
Yes.
and we saw how different pulse with modulator given to the different. Then we saw the ladders. Now we'll see different motherboard power sequence. Like the motherboards, these are the main manufacturers of the laptop motherboards.
Okay.
Like HP, Acer, COMPAL, they are not making the motherboards. So these are the companies who making the motherboard. Like the COMPAL. The COMPAL is making the motherboard. And the COMPAL number start from LA44 something. Number start from LA.
Earlier.
The number start from LA. Then the QUANTA. The QUANTA number start from RA something like
Okay.
R13. So then WISTRON. Most of the Dell laptop made by WISTRON. Then the Inventec. So these are the 4 manufacturers who make the motherboards, and all their power sequence are little bit different. Their concept is little bit different. That we are going to understand. So first you have to, when you have a laptop, first you have to see who is the manufacturer of the motherboard. Like morning, what you see in the motherboard, that is a WISTRON. That motherboard is a WISTRON. This motherboard is a QUANTA. That motherboard is a WISTRON. And this motherboard is a COMPAL. Numbers start from LA. Okay? And his power sequence is different. This power sequence is different. And that power sequence is different. Okay? So first you have to find out like that. So this COMPAL, QUANTA, Inventec, WISTRON, and other is a Foxconn is also there. And Asus and Samsung is also there, but these are the main 4 major manufacturers. So first we'll see the COMPAL motherboard power sequence. First we'll see the COMPAL motherboard power sequence. So how the power flow. So in this one is a processor, PCH, SIO, EC bias and PCH bias. These are the main component. Now how it will work, how they will work. First, here are the 2 input. One is an adapter, another is a battery, and when we connect the adapter and battery, the adapter voltage goes inside, and this line is called the volt-in line, where I will get 18 volt or adapter volt, it may, whatever it may be. How much volt will be here? 18 volt. We'll assume 18 volts. So, and these square boxes are the pulse width modulator. These boxes are the different pulse width modulator. So this is called the always voltage, who generate the 3.3 and 5. This is called the 1.5 voltage for RAM. This is called the system voltage 1.8, 1.05, and this is called the CPU core voltage. Right? So now when I connect the adapter, all this section work only after they get enabled. All this section only work after they get enabled. Only this section work directly. So once he receive the input voltage, he generate this 3.3 and 5 volt. See? And this, see how the voltage is going. Now this 3.3 given to the SIO and 3.3 given to the EC bias. Both the chip got the power, and this 3.3 and 5 voltage stop here. This 3.3 and 5 voltage stop here, not allowed to go ahead. Now here also 3.3 stop. Now my third sequence is on off switch power button or NBS on. Here I am getting a 3 volt. When I press a power button, a 303 pulse will be generated at this terminal at power button or NBS on, and then SIO omit one signal, that is called a PCH enable signal, and trigger this MOSFET. At step number 4, it trigger this MOSFET, and once it trigger this MOSFET, this 3 volt pass this MOSFET and reach to the PCH, and now PCH got the power. This 3 volt you can check on this capacitor also. Once the PCH got the power, after 10 millisecond, SIO will send another signal. Every 10 millisecond, he take a delay. So after 10 millisecond, SIO omit another signal, that is called RSM RST, resume and reset, 3 volt. Okay, then he send a power button. If this signal not comes out, then there is a possibility that SIO or EC bias may be faulty.
That resume and reset, it will come without power button, no? Without pressing.
Without power button, it will be 0 volt RSM RST.
Okay.
Once you press power button, it goes 3.
Otherwise, without pressing power button,
0. It will 0. Without pressing a power button, it will be 0. Once you press a power button, RSM RST will be 3 volt.
and power button also 3 volt.
Power button is always 3 or 0. But once you press the power button, here you will get a variation that 3 become a 0 and back to 3. There will be a pulse will be generated.
Both side. This side power switch and this one.
Yeah, same.
Same.
So here a pulse will generate. This is called the PM power button. Sometimes it's called the DNB power on or PM power on.
Okay.
It's called a post power on.
Okay.
Saying to PCH that ki power button is pressed. Now the time to PCH to respond. Now PCH has to respond. If the PCH find everything is okay, if there is a no problem, PCH send a 2 signal that is called SLPS3 and SLPS4.
Okay.
These are the 2 wake up signal. These are the 2 wake up signal called a slip mode 3 and slip mode 4, like this. Slip mode 3 and slip mode 4. If this signal not come from the PCH, then the PCH is a bad.
Okay.
Now these 2 signal are the confirmation signal to the SIO to turn on all voltages. Once he got the confirmation, he started generating a different signal. So first he release first signal that is called a system on.
When they receive SLP S3 and
Yeah,
SLP S4.
after that step number 8, after step number 9, system on. When he release the system on, 1.5 voltage will be generated.
That is RAM.
That is a RAM. 1.5 given to the RAM and 1.5 given to the PCH also.
Okay.
If it is a DDR3 RAM, if it is a DDR3L, it will be 1.35.
PCH in RAM control.
Yeah. So 1.5 will be generated. Then he send out the next signal that is called SUSP signal. Suspend on signal. After 10. Suspend on signal when he generate that time the halt voltage which is here 3.3 and 5 will pass. Pass this MOSFET
Okay.
and 3.3 voltage from here it will pass this from drain to source
Okay.
and become a 3 volt suspend. 5 volt always become a 5 volt suspend and spread entire the motherboard wherever there is a track or requirement. The next is 1.5 voltage will be generated and the finally this is called the system voltage, that is called a 1.05 voltage will be generated.
Okay.
And this 1.05 voltage given to the processor and to the PCH. This 1.05 is a VTT voltage is given to the CPU and the PCH. And once this voltage come out, this section generate a one signal that is called a SA power good. He generate a SA power good and this SA power good given to the SIO. Now SIO, when the SIO got this signal SA power good, he released the next signal that is called a VR on. He will not going to release VR on unless and until he not receive this signal.
Okay.
So if he receive a SA power good, then only he will release the VR on signal. So sometime what is happening, your laptop is on but core voltage is not coming. So why the core voltage is not coming? So you have to check the VR on signal. So VR on signal is not generating. So why VR on signal is not generating? Because he is not receiving the SA power good. Now SA
Where it will come from? SA power.
from this section, his power good to this chips, to the
All
pin.
regulators generate.
All generate power good, but this power good is very important.
What is the?
1.05 volt.
That is.
The 1.05 volt, that is the system voltage to the CPU and PCH.
Okay.
CPU and PCH 1.05 voltage. This 1.05 voltage given to the CPU and PCH and is power good given to the SIO. Once SIO got this signal, it turn on the VR on voltage and core voltage will be generated. CPU core voltage, see, a CPU core voltage will be generated, and CPU generate a two level of core voltage, that is, one is a CPU core and another is a graphics core. CPU core for the CPU core sections and graphics core for the graphics core sections. That voltage approximately 1 volt, maybe 0.8, 0.9 or 1.1, in that range. But here is a huge current is required, more than 30 ampere current is required. So that given to the processor, to the CPU. Now once the CPU got the power, CPU have his own power management department. When he received the power, once he received the power, he respond via VID signal, that is called a voltage identification signal, is a two-wire communication protocol. In older motherboard there is a 8 binary signal, that is called a VID signal. But in the latest motherboard there is only two-wire communication. This is called a serial voltage identification signal, a two-wire communication protocol like SM bus, where a CPU communicate with the VRM section. CPU communicate with the VRM section, VRM chips, and tell him the acknowledgement, the power he got. And if he got something less or more current, he acknowledge VRM section and asking a demand for more, something like that. So this is called the VID signal. This signal you can check on the help of oscilloscope. That means your CPU is alive, CPU is responding. So once CPU communicate with this and voltage is stabilized, then there is a after this both the signal, there is a one signal generate, that is called a VRM power good. The VRM power good or the V gate, the signal means the VRM section working fine. VRM section is okay. There is not a problem in the VRM section. And then PCH also generate a PCH power OK signal, and both signal will join each other and they generate another signal, that is called a system power OK. They will generate a system power OK signal. When PCH receive this system power OK signal to the PCH, he will come to know that all power good, all power is stable, like we seen in ladders, or everyone chip got voltages, and then the confirmation power good. So this one is your power good signal, where the confirm that all chips got a power and my all power plant is working fine. So if you check this signal, that means you no need to check the previous signal. If
power is okay.
All power is okay, system power okay, means all power is okay, no need to check or other powers plane. And once the PCH receive this signal, he is ready to generating this three signal one by one. So he will first release the DRAM power OK signal. He send the DRAM power OK signal. The DRAM power OK signal means the RAM to the power to the RAM is okay. RAM got the power and he tell the CPU, he informed the CPU that you are ready to communicate with the RAM. And then CPU generate another signal, that is called a DRAM reset. At pin number 30, RAM pin number 30, you can check this signal, that is called a DRAM reset at pin number 30. If when this signal is released, CPU release the another signal, that is the DRAM reset. So once you check the DRAM reset on pin number 30 on the RAM connector, that means this signal is obviously okay. Then PCI generate the next signal, that is called a CPU power OK. The CPU power OK means the CPU got all the power. CPU got 1.5, 1.05, 0.85, CPU core, graphics core, 5 voltages is required. So all 5 voltages are okay, and this signal tell the CPU that you just ready to do work. And finally he generate the next signal, that is called a PLT reset. The PLT reset means the platform reset, where this signal reset the entire motherboard. Reset the entire motherboard, including the CPU. Including the CPU, and CPU get reset over here. And once the CPU get reset, he access the DMI bus. And this PLT reset you can check on so many components, like you can check on the SIO, it's called a reset signal. On LPC bus you can check on the Wi-Fi card also. At pin number 22, there you should get a 3 volt. If 3 volt coming on the pin number 22 of the Wi-Fi port, that means the rest of the all signals are okay. You no need to check the previous signal.
All voltages is okay.
All voltage, obviously, all.
Also.
If 18, yeah, if 18 step, see, because here is a sequence from 1 to 10, it's going by sequence.
Yes.
It's not going by lump sum, it's going by one. So 18 sequence, that is a PLT reset is coming, that you check on the Wi-Fi card pin number 22. That means all the previous signals are okay. Okay. So after PLT reset, once CPU got the clock, and he access the PCH like this, and he access the BIOS. He access the BIOS. BIOS pin number 1 is a chip select, BIOS pin number 2 is a read. He give it to the clock at pin number 5 and read the BIOS. This on when you connect the oscilloscope on BIOS pin number 1 and pin number 2, you will find the signal, some waves. Some waves are coming. You can check on pin number 1, connect the oscilloscope on pin number 1, keep oscilloscope on 1 volt, start the laptop. You should see some waves. If these waves are coming, that means CPU is accessing the BIOS via DMI bus. If there is a flat, there is nothing variations, that means something wrong with the CPU or the PCH. Okay, so in this way this COMPAL motherboard power sequence work. This is a concept of the power sequence of COMPAL laptop motherboard.
If waves is okay in RAM chip,
RAM chip where?
that pin number 1.
RAM? No, this is not a RAM. This is a BIOS.
Sorry, bias.
Huh.
That processor is okay and PCH is okay.
We can assume. If we find pin number 1, there is a waves. If there is a wave, means obviously all sequence are okay, and CPU accessing the BIOS, and we can assume that they may be okay. It's not 100% because the PCH have so many departments.
But bias is okay or not?
Bias is okay, we can't confirm with the help of oscilloscope, because we can see some pulses, but the pulses are perfect or wrong, that we can't say, because bias is a 4 MB or 8 MB. One of his bit or one of his byte may be corrupt also, that we can't say. For that we have to flash the bias and check. But when we have to flash? When there is a no display. This PCH bias is responsible for the display, and EC bias is responsible to power on. If your laptop is not powering on, it's not giving the RSMRST, you have to flash EC bias. But if your laptop is not giving display, then you have to flash a PCH bias, because the PCH bias work on suspend voltage. This suspend voltage, and
same program, different.
no, different program. This bias is a 128 kb, and this bias is a 4 MB or 8 MB. So program is a different. This one is a smaller in capacity, 128 kb, 256 kb. This is more capacity. So these are different. Okay. So next section we'll see the QUANTA motherboard. In last screen we seen COMPAL motherboard. Now this is a QUANTA motherboard. The QUANTA motherboard power sequence again little different compared to the COMPAL. In QUANTA motherboard, same components are same, like processor, PCH, SIO, RAM, ठीक है? Then bias, then these are the different pulse width modulator. Now input is same, adapter and battery. When I connect adapter and battery, adapter voltage come down, that is 18 voltage, and given to the different pulse width modulators. The pulse width modulator are the same, like the COMPAL. Now in this section, a linear 3.3 voltage will be generated, not the always voltage. Linear voltage and pulse width modulator voltage are the different. So the linear 3 voltage will be generated. You have to go by sequence 1, 2, 3, 4 like that. So after 1 there is a 2. So linear 3 voltage will be generated, and the linear 3 voltage given to the SIO. Now SIO got the power. Now we will hold there only. Wait to power on button to press. Wait to the power on button to press. In power button, it's called a NBS on or power button or power switch. This pin is, there is a 3 voltage is there, and the next terminal of that switch is 0. It's connected to the ground. When we short the switch, that time the 3 volt become a 0 volt, and we release it back to 3. So that means here is a 303 pulse will be generated. 303 pulse will be generated, and once you receive a 303 pulse, the SIO send out the next signal is called SLPS5. He send out SLPS5.
That is enabled.
SLPS5 given enabled to this pulse width modulator chip. Suppose here they use a TPS 51125. So the TPS 51125 require enable signal to start pulse width modulator. So once he receive this enable signal, then only will start. Now if when we press a power button and SLPS5 signal is not coming out, then there is a SIO faulty, maybe SIO not getting power, maybe EC reset is there, or maybe EC bias may be corrupt. Okay, so once this pulse will be generated, there will 3 and 5 voltage will be generated. Always 3 voltage, always
Only
5 voltage will be
Press
generated.
the power button, only SLPS5 is
Yes, in QUANTA.
in QUANTA.
COMPAL is a different, QUANTA is a different, WISTRON is a different, all their rhythms are different. So we are learning QUANTA motherboard. So SLPS5 signal goes out and it generate at 5 number, right? And then 6, here PCH got the power, and at 6 RSM RST signal will be generated. You can check the RSM RST, 6 number, 10 millisecond delay, PM power button, next signal. After that he wait for SLPS3 or SLPS4 signal, both the signal from PCH. If these signals are absent, then PCH may be faulty. So you have to check this SLPS3 and SLP4. The alternate name for the SLPS3 and SLPS4 is SUSB and SUSC. These are the alternative name. Okay, so you have to wait for this signal. Once he receive this signal, what SIO will do? He first trigger this signal. This called the SUS on. SUS on means suspend on, where he trigger this both the MOSFET and pass the voltage to the, just like a river, he pass the voltage to the next side. Means if this terminal is a drain, when he trigger to this gate, the drain voltage pass to the source. The drain voltage pass to the source. Okay, so this is a step number 9. At step number 10, there is a next signal is called a sys on. The sys on means the system on. When he generate the sys on signal, 1.5 voltage will be generated,
Let's go to RAM.
and 1.5 given to the DDR3 RAM and the PCH. and the processor also. And step number 11, there is a next signal is called the main on. In Quanta motherboard, the next signal is main on. When you trigger the main on to this two pulse width modulator, one is called 1.8 and another is called 1.05. At that time, from here 18 volt, 1.05 and 1.8 voltage will be generated. Right? So this all the voltage will be generated. Now each section have their own power good. The power good signal means every pulse width modulator have a two signal. One is the input, another is the output. Input signal means the enable signal. This is a 3 volt signal. It's called the enable signal. And once that section is okay and ready to work, that time this particular pulse width modulator generate a send out another signal is called the power good. The power good signal means that particular department is saying ki my department is okay, is working fine. It's called like an acknowledgement. Suppose I said this guy to do this work, so I gave him enable. So now he do his job. He done that job, and after completing his job, he tell me that yes, I done my job. That is the confirmation he is done. That is called a power good. Similarly, in each pulse width modulator, they have a two signal. One is called the enable, another is called the power good. Now this all pulse width modulator generate their power good. They are gathered together at this terminal. They are gathered together at this terminal, like always voltage, suspend voltage, main voltage, system voltage. All voltages are power good gathered together. They connected to each other, and that cumulative, that connected terminal is called HWPG. The HWPG means the signal. If here is a 3 volt, that means your all power streams are okay, except CPU. Because CPU is a king. CPU is the last component which is going to on. And CPU core voltage is the highest current. And before to generate that highest current, the motherboard require rest of the voltage should be on before to turn on the core voltage. Right? So they make sure that all voltage should be okay before CPU to turn on. Any of this voltage will be absent. Suppose 1.5 voltage will be absent, that is the system voltage. So here it will be 0 voltage. That means the short to the ground. So if any of the all voltages are okay, but suppose the 1.5 is not okay, output here the HWPG will be a 0 volt. And if the HW is a 0, core voltage will not turn on. Okay. So if the HWPG is a 3 volt, then only core voltage will be generated. So once the HWPG generated a 3 volt, this SIO send out a final signal, important signal, is called VR on. He send a VR on signal 3 volt to the CPU core section. It's called the VRM section, voltage regulator module, CPU section, where they generate a huge current to the processor and to the graphics, and that is called a CPU core and the graphics core. That voltage approximately 1 volt here and there, some 0.91, but there is a huge current in 30 amperes current that given to the processor. And once the processor receive this voltage, he communicate processor to the VRM section via SVID signal, serial voltage identification signal, and they communicate with each other, and the voltage will be stabilized. And once the voltage is stabilized, the VRM section generate a next signal that is called IMVP power good. The IMVP power good means the VRM section is okay, the VRM section is working fine. That is called IMVP power good. means all section is okay. And once SIO receive this IMVP power good, SIO generate the next signal is called EC power okay or system power okay. EC power you can check on this SIO pin. It's mentioned on the SIO. EC power okay or system power okay. If there is a 3 volt, that means this all power planes are okay. Got my point?
Yeah.
If you find a 3 volt at EC power okay, means all voltages are okay.
All voltage is okay.
All voltages are okay. No need to check previous voltage. If this here is a 0, then you have to go back. You have to trace out which voltage is not turning on and why. Now once the PCH got this signal, the PCH is ready to communicate with the processor and he send the next signal, that is called a DRAM power okay. Like in COMPAL motherboard, he generate the DRAM power okay, and after the DRAM power okay, processor generate the next signal is called the DRAM reset. The DRAM reset is a 1.5 voltage reset to the RAM. Reset to the RAM. This voltage you can check on the pin number 30. You should get a 1.5 volt if the DDR3, and if it's the DDR3L, here will be 1.35 voltage. And if you find voltage here, that means PCH send DRAM and CPU is okay. CPU is most probably okay, and you omitted DRAM power reset. After that, CPU send the next signal is called a CPU power good. Then is next signal called a PLT reset, platform reset. The platform reset is a 3 volt, and this 3 volt reset the entire motherboard. But when it reach to the CPU, they use here as a resistor to drop that voltage, because CPU is the maximum voltage with 1 volt. So how can give the 3 volt to reset? So they use a resistor over there to drop the value. So that voltage is called the CPU reset. And when the CPU get reset, and when he receive the clock, that time he access the PCH and access the PCH bias and read the bias. Right? So in this way, this QUANTA motherboard concept is work. So we seen a COMPAL motherboard and then the QUANTA motherboard, little bit different.
Yes.
In COMPAL and QUANTA, a little bit different. Now we'll see a third motherboard which is more different. That is called a WISTRON motherboard. WISTRON normally used on Dell laptops. Like there is a 6-digit number and it's written -1, -2, -3, something like that. In COMPAL is a LA, right? So this is called the WISTRON motherboard. WISTRON motherboard power sequence is little bit different. So we're going to understand this concept now. Okay. So here same component, CPU, then PCH, then SIO, then PCH bias, and then EC bias. And here are my different pulse width modulator. Here my different pulse width modulator. And these are my adapter input and my battery input. Two inputs are there. Once I connect adapter and battery, 18 volt pass here and given to the different pulse width modulator. This one is called the always voltage, where they generate a 3.3 and 5. This section is called a 1.5 voltage for the RAM, 1.8, 1.05, 0.85, and finally CPU core and graphics core. Okay, so these are the different pulse width modulator section. These are the different pulse width modulator section. So once this 18 voltage passes to the different pulse width modulator, this all pulse width modulator wait to get enable signal. They will not start unless until they get enable signal. Only this section will respond and he will generate a VREG3. Suppose if there is a user TPS 51125, there is called a linear regulator pin at Vin pin, and it's called a VREG3 and VREG5. That is called a linear regulator. So he generate the linear voltage 3 volt, and this 3 voltage given to the SIO and BIOS. That is step number 2. Once SIO got this signal, SIO immediately respond and send out S5 enable signal. In QUANTA motherboard, S5 enable signal reverse.
Yes.
Here is a reverse. S5 enable signal given to the enable signal to the this pulse width modulator. That's step number 3. Once he receive this pulses, this always voltage start generating the 3 and 5 voltage,
Okay.
and that will halt here. Step number 4. Okay. And PCH also get the power. PCH also get the power. And step number 5, RSM RST will be generated. In QUANTA WISTRON, RSM RST generate before power on button press. These are different.
Okay.
So RSM RST already generate before power on button press. After that, 6 number power on button, power on switch, 303, same pulse on off switch. Then 7 number PM power button will be generated, 303 pulse will be generated, 7.
Okay.
Once SIO send this signal to the PCH, PM power button, PCH respond and he send out a 2 signal that is called same SLPS3, SLPS4. But after that, the entire concept is different. SLPS3, SLPS4 given to the SIO, confirmation that to turn on the laptop. But here is a no role to the SIO to turn on the motherboard. In QUANTA and in COMPAL, SIO is responsible to turn on all this pulse width modulator.
Yeah.
In WISTRON, SIO is not responsible to turn on the motherboard. He get only the acknowledgement from the PCH that okay, turn on. But here PCH only turn on all this power sequence. So he SLP S4 signal given to this 1.5 volt,
Okay.
and this 1.5 volt will be turned on, right?
Yeah.
This RAM supply will be turned on. SLP S3 signal is sent out, and this SLP S3 signal given to this section, the sustained voltage which is halt here, which pass
Okay.
1.5 sustained, which stop, which will pass,
Okay.
right? And then this voltage given to this 1.8 same. And when this 1.8 enable is given, then 1.8 voltage will be generated and is given to the PCH at step number 11. When 1.8 voltage will be turned on, that time 1.8 power good signal out when this voltage is stabilized, and that power good signal given to the enable to the 1.05. His power good signal given to his enable.
Okay.
You understood?
Yeah. Yeah.
His power good signal like a Coco
Okay.
game,
Yeah,
you know,
yeah.
his power good signal given to the enable. That signal is called a run power. Okay. Then 1.05 will be turned on, and he generate a 1.5 voltage. Now his power good signal given to his enable, and that signal known as VTT power good. Then his power good signal given to the CPU core, that is called IMVP VR on, and then the CPU core voltage will be generated, and CPU generates the 2 core voltage. One is graphics and a CPU. Again, this is a SVID signal same. And when the CPU core voltage running perfectly, at that time CPU generate a IMVP power good signal. IMVP power good signal means CPU section is okay, and that voltage name become again a system power okay. So this cycle is going from start from here and goes like this and come back to here. So when he turn on, he wait for 20 millisecond. When he send out this signal, he wait for 20 millisecond to receive this signal. Within the 20 millisecond, if he not receive system power okay signal, then he turn off all the signal.
Okay.
You getting my point?
Yeah.
So he turn on, he on, then he turn on next, receive,
Okay.
acknowledgement. That is system power okay. And once he receive that system power okay, that means your all power streams are okay.
Okay.
And once all the power system are okay, the rest of the signal like a same DRAM power good, CPU power good, PLT reset, DRAM reset, everything is the same. And finally CPU access a BIOS. So in this way this system work in WISTRON motherboard. So I explain you QUANTA, COMPAL and WISTRON motherboard, a power sequence. Each have a little difference. So when you have a motherboard in your hand, you have to see the model, we have to see the number, and you have to understand the which model it is, and if it is a laptop, the dead, you have to follow this chart, whether it is COMPAL, QUANTA or WISTRON. So in this way this system works.